Have you ever thought about how some materials just seem to defy the basic rules of math? Where you combine two things and what you get isn't just twice as good, but something exponentially better. Well, today we're diving deep into the world of these super materials.
So, to kick things off, we're going to look at this hidden connection, this secret thread that ties together some of the most high-performance gear you can possibly imagine, from a Formula One car to a pro-level tennis racket. So let me just ask you this. What on earth could a stealth bomber, a gigantic wind turbine blade, and a bicycle so light you can pick it up with one finger? What could they possibly have in common? I mean, they seem like they're from completely different worlds, but they all share the exact same secret to their incredible performance.
And the answer is, they're all built with composite materials. That's the term for today, folks. This is the concept that makes all of this amazing technology a reality.
Okay, so what is a composite, really? Let's get right to the core definition, because once you grasp this, you unlock the secret of how these super materials actually work.
At its heart, a composite material is actually a pretty simple idea. You just take two or more totally different materials, you combine them, and the result isn't just a mix, it's a brand new material that's way, way better than any of the ingredients could ever be on their own.
You can think of it like the ultimate material teamwork. You're not just adding their strengths together, you're multiplying them. The whole goal, the entire mission, is to make 1 + 1 = 3.
So how do we pull off this kind of material magic? Well, it turns out every composite has a basic recipe, and there are two key ingredients. So let's break down that recipe right now.
Every single composite has these two parts. First, you've got the matrix. You can think of this as the binder or the glue. Its job is to hold everything in place and give the object its final shape. And then you have the reinforcement. This is the muscle. This is where the raw strength and stiffness come from. The muscle fibers take all the punishment, and the binder makes sure that punishment gets spread out evenly across all those fibers, so they all work together as one.
Now, the absolute best way to wrap your head around this whole binder and muscle idea is with an example you've probably seen 1,000 times and never really thought about it: reinforced concrete. Okay, so in this analogy, the concrete itself, that's our matrix. It's awesome at being compressed, and it can hold a shape like a champ. But it's brittle. It can crack. That's where the steel rebar comes in. That's the reinforcement. The steel gives it incredible strength when it's being pulled or stretched. You put those two together, and bam, you get a material strong enough to build skyscrapers. It's so much stronger than just plain concrete or plain steel could ever hope to be. And this is the exact same principle behind all those high-tech materials. For the reinforcement, the muscle, we use things like ultra-strong carbon fiber, fiberglass, or even aramid, which you might know by its brand name, Kevlar. And for the matrix, the binder, we use advanced plastics like epoxy resin or other high-tech polymers.
All right, so we get the what and the how, but what about the why? Why go through all this trouble in the first place? Let's talk about the superpowers that make these materials so incredibly useful.
At the end of the day, the core mission is to create a material that has a combination of properties you simply can't find in nature. It lets engineers become designers, picking and choosing the exact properties they need for a specific job.
I mean, just look at this direct comparison. Let's put traditional steel up against a carbon fiber composite. Steel's strength-to-weight ratio? It's good, not great. Carbon fiber? It's absolutely exceptional. Steel rusts, right? It has poor corrosion resistance. Composites? They're excellent. They don't care about rust. And design flexibility? Forget about it. You can mold composites into these wild, complex, aerodynamic shapes that would be totally impossible with steel.
And here it is, the killer stat, the knockout punch. Carbon fiber can be 5 times stronger than steel at just a fraction of the weight. Just let that sink in for a second. That one fact has completely revolutionized entire industries, from aerospace to professional sports.
So this isn't just about the cool stuff we can build today. This is way bigger. This is fundamentally about what we're going to be able to build tomorrow. The future is, quite literally, being composed. So if you only take away one thing from all this, let it be this simple 3-step process. 1, you combine a binder with a muscle. 2, you use that combo to create a brand new material with tailor-made, superior properties. And 3, you use that to build things that are stronger, lighter, and more efficient than we ever thought possible. What this all represents is a really profound shift in thinking. For pretty much all of human history, we were limited by the materials we could find laying around. Now, we are moving from an age of material discovery into an age of material design.
where we can literally invent the perfect material to solve a specific problem.
And that leaves us with one final, fascinating question to chew on. If we can truly design materials, maybe even atom by atom, for any challenge we face, what are we going to build next? What impossible things will suddenly become possible?